Okay then, so if there's no homework or no questions from last night's homework, we'll just kind of get started then. If you guys decide to change your mind, just let me know. We can always kind of backtrack. Today, we're going to start by talking about a shortcut to polynomial division. That shortcut is called synthetic division. And like all shortcuts, we can't use it all the time. So we can only do synthetic division when both the degree and the leading coefficient of the denominator are 1. So what does that mean? If we go back and look at the homework from last night, we had 3 polynomial division problems. So the divisor is the second number. If I look at this, well, the leading coefficient on x minus 5 is 1, and its degree is 1, so I could do synthetic division on this problem. If I look at the next one, the divisor is x plus 1, so the leading coefficient is 1, and the degree is 1, so I could do synthetic division on this problem. If I look at the last one, though, the leading coefficient is 1, but the degree is 2. So I couldn't use synthetic division on this problem. It doesn't matter what the divisor looks like. Only the it doesn't matter what the dividend looks like. Only the divisor. So let's do an example here. So let's do number 8 from the homework last night. And we'll show you how much easier that is when we use the synthetic division shortcut. Okay, so the first thing we do is we take our divisor and we set it equal to 0 and we solve. So that's very easy. And we're going to draw that same kind of setup that we did for synthetic substitution. And the number that's going to go on the outside is whatever the solution is to the denominator set equal to 0. And just like synthetic substitution, my bar are going to be the coefficients for my polynomial. So that's the setup. The first step, or the steps now for synthetic division, are the exact same as the steps for synthetic substitution. So begin by bringing that first number down. And we take the outside number, we multiply it by that number underneath, spot, and add down. So 5 times 2 is 10. and negative 9 plus 1 is, or plus 10 is 1. Then we do 5 times 1. We write our answer in the next spot. Negative 12 plus 5 is negative 7. And we keep repeating, so 5 times negative 7 is negative 35. We add down, that gives us negative 6. And 5 times negative 6 is negative 30. 30 plus negative 30 is 0. And we're done. Synthetic division is now over. And you'd probably go, wait, what? Where's the answer? Well, these numbers at the bottom are going to tell us our answer. It's just about learning how to interpret what these numbers at the bottom of our synthetic division problem mean. So we always read from the right to the left. The very first number is the remainder. The next number is our constant term. The next number is our x coefficient, and then our x squared coefficient, and then our x coefficient. So the degree of our x's just keeps increasing by 1 as we move from left to right. So we'd say our answer then is x cubed plus, 2x cubed plus x squared minus 7x, 6, and since the remainder is 0, I don't have to do anything else at the end. That's just going to be my final answer. So remember yesterday when I mentioned that the synthetic substitution process was going to become useful again? Here it is, becoming useful again. We're using that same process to do something that's much more complicated than substitution. And this is a massive shortcut compared to what it took to do this same problem by hand. So it's much less space, it's much faster, it's much fewer opportunities to make mistakes. It's a very, very nice process. Let's do another. Okay. So we'll start by taking our divisor, setting it equal to 0, and then solving. And then we draw our synthetic division bar. That solution to the divisor set equal to 0 goes on the outside. And then the coefficients from our dividend go on the inside. But notice here on our dividend, fourth term, we have no x cubed term, and we have no constant term. So we're going to make sure that we include zeros in each of those spots. You must include those zeros, or this will not work. So, first step is we bring down that very first number. We do negative 2 times negative 3. Write our answer in the next spot and add down. Then negative 2 times positive 6 is negative 12. And then we add down. Negative 2 times negative 12 is 24. And then we add down. Negative 2 times 31 is negative 62. We add down. And negative 2 times negative 68 is 136. And we add down. So again, the synthetic division is not done. So the first number on the right is the remainder. We're always reading these numbers from right to left. The x coefficient, the x squared coefficient, the x cubed coefficient, the x to the fourth coefficient. So when we write our answer, that's going to be negative 3 x to the fourth plus 6 x to the third minus 12 x squared plus 31x minus 68 over our divisor, which is x plus 2. Again, so nice, very fast, very compact, very few opportunities to make, like mistakes in the same way that the polynomial long division, there was so many little multiplications and additions that there was lots and lots of opportunities to like drop a negative sign or multiply something wrong. Here it's much fewer of those opportunities to make mistakes, which is nice. It's compact. It doesn't take a lot of space on your paper. It is really quite a wonderful method. As we continue talking about factoring and solving of polynomials in the second semester, we're going to be especially interested in dividing polynomials by these, linear terms like x plus 2 and x minus 1. So we're going to have lots and lots of opportunities to take advantage of this really nice method later on in second semester when we continue talking about factoring and solving polynomials. So that's really, really quite nice. So we'll do that. We've done that now. Any questions about synthetic division before I move on to the next thing? Okay. So here we're going to start talking about factoring polynomials. And today we're going to talk about 3 techniques. We're going to talk about sum of 2 cubes. Cubes is this. Talk about the difference of 2 cubes. This factoring pattern is this. And we'll talk about the difference of 2 squares, which we already mentioned in the previous chapter, but we'll apply this now to polynomials, so things that might have like x to the fourth or something in it instead of just x squareds. Okay. So let's do some examples. Let's say we have x cubed minus 8. Since I see an x to the third, I immediately start thinking maybe I have 2 terms. So I have something cubed and I have just 2 terms. I should immediately start thinking maybe I could do the sum or difference of 2 cubes here. So I'm going to ask myself, is there a way to rewrite x cubed as something cubed? Well, sure. X to the third power is just x cubed. And then I'm going to think, okay, is there a way to write 8 as something cubed? Well, I know that 2 times 2 is 4, and 4 times 2 is 8. So I know 2 to the third is the same thing as 8. So that tells me my a is x, and my b is 2, but I realize a difference of 2 cubes. So if I look at the right-hand side of my factoring pattern, I can fill in now for my values for a and b. So I'll have x minus x squared minus x times 2 plus 2 squared. And then we'll just clean things up a little bit. X squared is just x squared. X times 2 is 2x. And 2. So there's my final answer. Okay. Let's do another. Let's say we have 27x cubed plus 125. So again, I see that x cubed sitting there, and I start thinking to myself, maybe I can think of this as a sum of two cubes problem. So I need to try to rewrite 27x cubed as something cubed. Well, 27 I recognize 3 times 3 is 9, and 9 times 3 is 27. So 27x cubed could just be the quantity 3x cubed. Then I should look at 125. Well, I know 5 times 5 is 25, and 25 times 5 is 125. So I know that 125 is 5 cubed. So I know I have a is 3x. And the situation I'm in is the sum of two cubes factoring pattern. So I'm just going to plug those values for a and b into that factoring pattern. So I'm going to have a plus b times a squared minus a times b plus b squared. And then we'll just clean things up a little bit. So 3x times 3x is 9x squared. 3x times 5 is 15x. And 5 squared is 25. Okay. So let's do another. What if we have 16? Well, since I have an x to the fourth here, I know that I don't have a sum or difference of cubes because I need an exponent that's divisible by 3 for that to happen. So x to the fourth is not going to work. So maybe I can write this as a sum or as difference of two a difference of two squares. So x to the fourth I know is the same thing as x squared squared, and 16 is 4 squared. So my a is x squared, and my b is 4. So when I go back and I look at my difference of two squares, I have this. So I'll just plug in my values for a and b into my formula. So I'm going to have a minus b and a plus b. But if I look at what I have here, I'm not quite finished because x squared minus 4 is also a difference of two squares, right? Here a is x and b is 2. That's one that we would have done last semester or last chapter. Squared plus 4, the sum of two squares is not factorable, so there's nothing to do with that piece. So x squared minus 4 becomes x squared minus 2 times x plus 2, and x squared plus 4 just stays the same. Will you always have a second difference of two squares to do? No. Not always. You know, if this was 25 instead, you'd have x squared minus 5 and x squared plus 5, and neither one of those are factorable anymore. but you do need to make sure that you're checking. Let's do another. About x to the 6th minus 1. Well, again, x to the 6th is even exponent, so I can maybe write this as a difference of two squares. So x to the 6th is x cubed squared. And 1, well, that's just 1 squared. So my a is x cubed. My b is 1 minus b times a plus b. I get x cubed minus 1 times x cubed plus 1. Oh, but look at these two. Each of these, the first one is a difference of two cubes, and the second one is a difference of two cubes. I know x cubed is just x cubed, so the a is x, and 1 cubed is 1, so I know b is 1. And similarly here, I know a is x. So when I do the difference of two cubes, I have a minus b times a squared plus a times b plus b squared. And then for the sum, I have a plus b times a squared minus a times b plus b squared. And then if I simplify things down and clean this up a little bit, x squared, x times 1 is similarly on this one, x times 1 is just x, and 1 squared is just 1. So there is my final answer. Any questions here about these factoring problems?
Mr. Kulik?
Yeah.
Can you scroll up a little bit?
Does that work?
Can you scroll up just a little bit more so it was like where it said like the sum of two cubes? Yeah. Like the stuff you highlighted. Thank you.
Mm-hmm.
Okay, I'm good now. Thank you.
Mm-hmm. Well, this is as much as I wanted to do today. So we talked about synthetic division, and we talked about these 3 factoring patterns. We'll talk about some more factoring patterns next time and solving, and that'll be the last thing we talk about in the semester. Today, though, I have the Chapter 5 Homework 2. So I have 4 synthetic division problems for you guys to try, and then 6 factoring problems to try. So that's your homework assignment for tonight. This will go into the last homework check, which is going to be Tuesday morning as the due date on. And also for today, I have this homework quiz 6. So I'm going to dismiss you from class here in a minute. When you get dismissed, you should start on this homework quiz. You can do the homework quiz on paper or in OneNote. If you're doing it in OneNote, please convert it to a PDF. And then there's an assignment drop box on PowerSchool. If you're doing it on paper, if you just have an image, you don't have to convert it to a PDF. You can just take your picture file and upload that into PowerSchool if you'd like. If you want to turn it into a PDF, that's perfectly fine also. But this is the last homework quiz for the semester. And there's an assignment drop box on PowerSchool. So when you're dismissed, you should start on this assignment. Any questions about that? Okay. Well, you are dismissed. Have a good day. Good luck with your homework quiz. And we'll see you on Friday.
Have a good one.
Thank you. You too.